Moving along, we're getting into Module 3. So the first objective is to explain the considerations and procedures required to ensure a successful digitizing session. So first things first, we need to figure out what can we digitize, and then we're going to look at some of the digitizing methods and procedures. So what can you edit? The idea of a time, sorry, I'm going to trip over my words in this one today. When we're looking at this, it talks about editing features. So this is more on the vector data side. So we can see here that the ArcGIS Pro Basic version, you can edit shapefiles and geodatabase feature classes. You can, if you have the standard or the advanced version, you can digitize the geodatabase networks or the topological features or ArcInfo coverages, but we really don't recommend that. So this is not just digitizing, it's just editing. So can I change a vertex on a point, or can I move a line? Can I shift a point or like an object over? That is what we mean by editing in this case, not so much that digitizing, not yet. So while we're doing that and thinking, oh, okay, maybe I put a point in a wrong spot or something, so we've been able to edit, we also have to keep in mind coordinate systems. So in the old version of ArcGIS, you can edit across the coordinate systems, which just basically means that you can load different files with different coordinate systems. So that can be a little bit confusing when you bring in different files that have different coordinate systems, because something is not where it's supposed to be. And so you really had to spend a lot of time investigating what is the coordinate system of this data set? Can I project it into the right coordinate system so that it doesn't end up getting in the wrong spot, being in the wrong spot because it's in the wrong coordinate system? ArcGIS Pro actually uses something called projecting on the fly, and this is where everything becomes its own, or like the same coordinate system, not its own. So we start up a map, we start up a geodatabase, and it has a particular coordinate system. And then from there, every time you add data and say, okay, this is the coordinate system that it's in, it's going to project it on the fly, meaning that it's going to change the coordinate system of the data you're bringing in to match the coordinate system that it is using. So if you use edited coordinate systems or coordinates themselves, they're always saved to the source file, regardless of the map coordinate system. So if you move something based on another coordinate system, like the projecting on the fly, it still saves that change in the source file. So it's not relying on the map in the visualization. The projecting on the fly can degrade performance. So when you bring in data, reproject it before you start trying to do anything with it on the map, because it doesn't necessarily keep up with the speed, and if you have too many data sets open that are projecting on the fly, you could end up with additional errors. So it just makes it more stable. So then there's digitizing. So what digitizing is really looking at your data and creating vector information from it. So when you go to digitize and actually like draw something out, for example, let's say you're trying to get a lake off of an aerial photo, then you need to consider, like, does it make sense for me to use that digitizing technique or that digitizing option? So some of the things that are important is the scope. So again, does it make sense for the end objective or the end goal of that project? The accuracy requirements. When you digitize, you possibly can add error because you're now adding either human error or additional computer error. The project budget, because sometimes digitizing takes a really long time. Software and hardware of the computer and the capabilities of that. The digitizing medium that we're using, so the medium being like whether the computer or if we're using a paper that we're trying to digitize, or a scanned object. And then also training. Does it require training to be able to do? So looking specifically at software and hardware considerations, so we're not actually digitizing software. We're digitizing objects in software or objects in hardware. So some of them that exist. So when we're using hardware, you need a computer. There you'll have a mouse or something like a digital pen. There's something called a digitizing puck, which you can also use. Sometimes a tablet is important, and sometimes those tablets are not like what we consider a tablet with a glowing screen. They're actually just like a board that has um, some system in it that when you bring your mouse or the digitizing puck over it, it actually creates the digitizing. And then and a monitor, so a computer monitor to be able to see. When you look at the software for digitizing, just a couple examples is, for example, I can digitize in ArcGIS Pro, I can digitize in CAD, I can digitize in MapInfo. So then there's many more. So those are just a couple options. So what are the two main digitizing methods? There's a desktop method and a workstation method. So the desktop is what you guys are going to be using in this class. So there's really no configuration required. You're going to be using ArcGIS and you're going to use a mouse and that has clicking buttons on it. That's all you really need. It's really relatively inexpensive to do it this way. It has pretty good accuracy. Again, accuracy is based on the a lot of things. So when we say good accuracy, it just means that it's as good as you are able to do it, but also as good as the data that you've got. And there's a lot more that's added to that word, but we'll carry on. So limited user training is required. So again, I can teach anybody to do digitizing. I've actually I had my kids use when they have to do maps for school. I'll teach them how to use ArcGIS, and I get them to digitize stuff. So it's relatively straightforward in the ArcGIS. And then the digitizing medium is not really that important. Where if you have a workstation, this is very specific for a type of digitizing. It's considered a soft copy digitizing. It does require extensive configuration. You need a good computer, a fast computer. You need expensive monitors that allow you to do 3D viewing. You need 3D glasses, etc. And we're not talking like a 3D TV. We're talking something that's at least double that cost. It does have excellent accuracy because now you have a much better option of being able to really zoom in and see what's going on. It does require extensive user training, and usually you need a really good quality orthophotography requirement. So the photos themselves need to come in and be of great quality. So when we digitize the products, it depends on what we're trying to do. So a few examples of hard copy, which is stuff that you might have to scan in, historical drawings, topographic maps, aerial photography, and vector line work. Where soft copy, you can have all of those that have been scanned in. So that's one of the most common ones. Also aerial photography, so you'll notice that there's a base map in ArcGIS Pro, and that's all georeferenced and ready to go, so you can digitize from there. Satellite imagery is another one, and you can get all kinds of levels of precision and spatial resolution from that. And vector line work, so you have a bunch of lines and you want to make it into a certain shape, so then you would digitize that. So a few really useful tips is always have a backup copy of your original data, and have a backup copy of your digitized data, because you don't want to lose your work in general. Shapefiles are a very simple format to use as well, so you can digitize them or you can use them to save. Also, keep the number of open files down, because it gets really confusing if you have too many layers open, and then you might end up making a mistake. And then also keep everything in the same coordinate system. Reproject, we'll learn more about this later, but make sure that they're projected correctly. Don't just assume everything's projecting on the fly correctly. And finally, save frequently. Create objects, save. Create some more objects, save. If you want to save after every object, save. Whatever you want to do, you keep it simple. So this time you're going to go through chapter 8 and do editing, and you're going to complete the digitizing exercise, and then you're going to get started on assignment 2 for it. And that is everything for today.